Hello, 6th grade. Today we are going to work on Unit 1, Lesson 11, and we're going to talk about common factors and common multiples. So, since this is the first video that you guys have taken notes on this year, you basically just follow along. Fill in what I write, fill in what I say, and then if you need to pause or stop or rewind, feel free to do that. This is on your own pace, so take advantage of it. So we're going to use what we know about factors to kind of help start working this out. So the question says, Matt is running for student council. His friends are going to help him give out 15 posters and 6 banners. Matt plans to pack all of the posters and banners in boxes. He wants to put the same number of posters and the same number of banners in each box. What is the greatest number of boxes Matt can pack? So we're going to kind of use what we know to work through this. You know that Matt wants to pack the same number of posters in each box. There are 4 ways he can pack 15 posters. If he uses one box, there'll be 15 posters in each box. If he uses 3 boxes, he will pack each with blank posters. So 3 times what would give us a total of 15? Well, in this case, it would be 3 times 5. If he uses 5 boxes, he will pack each with 3 posters, and if he uses 15 boxes, he will pack each with 1 poster. So each one of these will equal a total of 15. So now Matt wants to pack the same number of banners in each box. There are 4 ways to pack the 6 banners. So just like up above, if he uses 1 box, he would have 6 banners. So then we can go through the same type of method. What numbers will multiply to 6? So let's say if he uses 2 boxes, he'll pack each with 3 banners. If he uses 3 boxes, he'll pack each with 2 banners. And if he uses 6 boxes, he will pack each with 1 banner. So explain how you could find the greatest number of boxes Matt can pack that have the same number of posters and the same number of banners. Well, we could look to see which number they both have in common. Sorry, iPad's being funky. So let's find out a little bit more. The number of boxes and the number of equal groups of posters are factors. The product is the total number of posters, 15. In Explore It, you listed all the factor pairs of 15. The number of boxes and the number of equal groups of banners are factors. The product is the total number of banners, 6. In Explore It, you listed all the factor pairs of 6. When you found the greatest number of boxes that Matt can pack, you found the greatest common factor of 6 and 15. So, greatest common factor. The greatest common factor of any 2 numbers is the greatest factor both numbers have in common. In the problem on the previous page, you found that 3 is the greatest common factor of 15 and 6. And you will see GCF listed a lot for greatest common factor. When 2 numbers have a common factor, like 15 and 6, you can write their sum, remember sum is addition, as a product using the distributive property. So, write each number with a 3 as a factor. So basically what we're doing is we're taking the 15 plus 6, that's our 2 numbers that we were using. And we're going to take each one and write it separately as a multiplication problem using the greatest common factor. So for 15, we can write 15 as 3 times 5. And then for 6, we can write it as 3 times 2. So then we can then take and look, what do they have in common? Well, in this case, they both have a 3. So I'm going to take that 3 and I'm going to pull it out and put it on the outside. Then I look at what I have left. I have a 5 and a 2. So I write 5 plus 2. And this is using the distributive property. Okay, we're distributing or taking out what they have in common and writing what we have left. So it says you can check that 15 plus 6 equals 3 times, in parentheses, 5 plus 2 by working it out. So we would do the 5 plus 2 first. When we do, we get 7, and then 7 times 3 is 21, and 21 equals 21, so we know that we have the correct answer there. So, number 1 says, explain how you could use the greatest common factor of 8 and 20 and the distributive property to write 8 plus 20 as a product. So, the first thing that we need to do is find the greatest common factor of 8 and 20. So, when we do, we can list them out. So we have 8, 1, 2, and 4. Sorry, that's a 4. And then for 20, we have 20, 1, 2, 10, 4, and 5. So, what is the biggest number that they have in common? In this case, it's a 4. So GCF equals 4. Okay, so if we were to follow what we did up above here, we would do 8 plus 20. What two numbers using 4 multiply to 8? Well, it's 4 times 2. Then what two numbers using 4 multiply to 20? 4 times 5. What do they both have in common? That 4. So we take the 4 and we put it on the outside. We're left with 2 and 5 on the inside. So it would be 2 plus 5. Alright, so let's focus on some greatest common factor for a little while. It says Alysha is putting cheese cubes and crackers into small plates. She has 24 cubes of cheese and 40 crackers. She wants both cheese and crackers on each plate, and each plate must have the same number of cheese cubes and the same number of crackers. What is the greatest number of plates she can use making all the cheese and crackers? So, you can list the factors and then circle what they have in common. So, as you can see in the model it. So they have a 1, 2, 4, 8 in common. Or you can make a table to show all the factors. Here you can see for the number of plates and the number of cheese cubes. And then you have the number of plates and the number of crackers. And once again, you would look through to find the greatest common factor. Or there's actually a third way. And the third way I'm going to show you, and it involves using our factor tree and our step division methods. So, we're going to work out 24 and 40 using our factor tree or step division. So, 24 would be 2 and 12. 2 is prime, we circle it. 12 would be 2 and 6. 2 is prime, circle it, and then 6 gives us 2 and 3, and they're prime, so we circle it. 40 can give us 8 and 5. 5 is prime. 2 and 4. 2 is prime, and 2 and 2. And the 2's are prime. So now what we would do to find the greatest common factor is we can now look for numbers that are both in 24 and 40. So in this case, I have a 2 here under 24 and a 2 here under 40. So I'm going to write down that they have a 2 in common. Then we keep going. I have a 2 in this one and a 2 in this one. That's another 2 that they have in common. I have another 2 here and another one here. So that's a third 2 that they have in common. So then what I do is they have nothing else in common because I have a 3 under 24 and a 5 under 40. Those are not the same, so they have nothing else in common. I take these three numbers and I multiply them. So 2 times 2 is 4, times 2 is 8. That means 8 is our greatest common factor. So make sure you have this written in your notes over to the side as a third way to do it. The steps for this are, first thing, factor out the numbers. Sorry, you have to bear with me. My iPad's a little silly. Okay, second thing is to find matches. Match up only what's circled. Okay, also make sure there's one number in each of your numbers you're factoring. You cannot have two of the same numbers under, for example, both under 40. You can't pair them up if they're under that same number. They have to be one in each. And then your final thing is multiply the matches. So now let's use the Connect It and answer a few questions. So it says, look at the list of factors on the previous page. What are the common factors of 24 and 40? Well, we mentioned this earlier. It's 1, 2, 4, and 8. What is the greatest common factor? So what is the biggest out of all these? It's 8. Look at the tables on the previous page. Can Alysha make 10 plates of cheese and crackers? Why or why not? Well, if we're looking on the previous page, do they have a 10 in common? So no, they do not, for that reason. They do not have 10 as a factor. And that means both numbers. Both numbers have to have 10 as a factor. 40 does, but 24 does not. So, can Alysha make 4 plates of cheese and crackers? Why or why not? Well, is 4 on both lists? Yes, it is. So we could say yes, she can put 6 cheese, because 24 divided by 4 is 6, and 10 crackers, because 40 divided by 4 is 10. So number 4 says, what is the greatest number of plates that Alysha can make if she uses all the cheese and crackers? Explain your reasoning. Well, what did we say was our greatest common factor? It would be 8. So we should say she could make 8 plates, each with 3 cheese cubes and 5 crackers. Okay, because 24 divided by 8 is 3, and 40 divided by 8 is 5. So number 5 says, what does the greatest common factor represent in this situation? The greatest number of plates Alysha can make. So now I want you guys to try a couple of these on your own. So we're going to use what we learned up above, look at your examples that we've done so far, and I want you to answer 6 and 7. So take a moment, pause the video, work through 6 and 7. Once you have tried them, resume the video and you can check your answers. Okay, so 6 says Amanda is making flower arrangements. She has 20 daisies and 16 roses. Each arrangement must have the same number of daisies and the same number of roses. She wants to use all the flowers. What is the greatest number of arrangements she can make? How many daisies and how many roses will be in each? So, I'm going to use the method that I show you using the factor tree or step division. So, I'm going to take my 20 and I'm going to factor it out. So I have 2 and 10 and 2 and 5. And then I'm going to take 16 and do the same. 2 and 8, 2 and 4, and 2 and 2. Then I'm going to go through and I'm going to find my matches. So I have a 2 on this side and this side. That's 1, 2 that they have in common. Oops, forgot to circle these. I have a 2 here and another 2 here. That's another 2 that they have in common. Now, I'm left with a 5 and 2 2s. These are in the same number, so I cannot count them as a pair. It has to be 1 and 16 and 1 and 20 for it to count as a pair. So, this is all I have in common. I'm going to multiply these, and I'm going to find that my greatest common factor is 4. That means she can make 4 arrangements. Now, to find out how many daisies and how many roses she can put in each arrangement, we have to take our greatest common factor and divide it into each one of the numbers. Okay, so we take our 20 daisies divided by 4 and we get 5. So we know that there'll be 5 daisies. And then we're going to take our 16 roses divided by 4 and we get 4 roses. Okay, now number 7 says use the GCF and distributive property to write 18 plus 45 as a product. So 18 plus 45. Now that we know our greatest common factor is 4, I'm going to write, we're not using the 4. These are 2 different numbers, so we have to factor those out. So 18 So 18 gives us 2 and 9, and then 3 and 3. And 45 gives us 5 and 9, and 3 and 3. So find our matches. I have a 3 here and here, so that's a 3 in common. I have a 3 here and here, that's another 3 in common. The 2 and 5 do not in common, so I'm done. 3 times 3 is 9. So 9 is our greatest common factor for 18 and 45. So I need to take 18 and write it as 9 times 2 gives us 18. And then I'm going to take 9 times 5, which would give us 45. They both have a 9 in common, so I take that out. And then I take what's left, which is 2 and 5, and that goes on the inside. So 18 plus 45, if I add them up, gives us, sorry about that, so I have 18 plus 45 gives us 63, and then if I come down here, 2 plus 5 gives us 7, and we're still multiplying it times 9. 9 times 7 gives us 63. So, yes, we know that our answer is correct because we checked it and it equals the same thing. Okay, now we have our least common multiple. So now we're dealing with multiples instead of factors. So the problem says Jackson wants to buy the same number of stamps and envelopes. Stamps are sold in packs of 6. Envelopes are sold in packs of 4. What is the least number of stamps and envelopes Jackson will have to buy? So we can picture it using a number line, and we can circle every multiple of 4 and then every multiple of 6. The least common multiple is the smallest number that is circled on both lines. Okay, so it's going to be the smallest multiple that they have in common. We can also model it to do similar to what we did with our factors, and we can write all the multiples out. We can list them out. The least common multiple is the smallest number that appears in both lists. Or we can also use our factor tree again, or our step division. So if we have 4, change it to the pen, 4 and 6, 4 factors out to 2 and 2, 6 factors out to 2 and 3. Now, the difference between greatest common factor and least common multiple. We still factor out our numbers. Okay, the second step is still to find our matches. And then our third step, which is our difference. So if we find our matches, we have a 2 here and a 2 here, and that's all we have in common. But this is where least common multiple changes. You bring down all leftovers. Meaning, if it doesn't have a match, so for example, our 2 and our 3 do not have a match, you bring those down with this. And then you multiply. So, 2 times 2 is 4, 4 times 3 is 12. Our least common multiple, or our LCM, would be 12. So, factor the numbers, find the matches just like before. Only now we bring down all of our leftovers. One way to remember whether or not you bring your leftovers is least common multiple starts with L, leftovers start with L. So on least common multiple, you bring your leftovers. Alright, so let's answer a few quick questions. Look at the picture. What multiple is circled on both number lines? Well, in this case, it's 12. What does this mean? That 12 is a common multiple. Look at model it. What are some common multiples of 4 and 6? Well, if we start looking through them, we have 12, we had 24, and we had 36. What do common multiples of 4 and 6 mean in this situation? Well, it's the number of stamps and envelopes that he can buy the same number. What is the least common multiple of 4 and 6? So it would be, once again, 12, because it's the smallest multiple for both. What does the least common multiple of 4 or 6 mean in this situation? It's the least number of stamps and envelopes that Jackson will have to buy to get the same number. Number 13, explain how to find the least common multiple of two numbers. Well, if we do like what the book was showing us, we can list the multiples and find lowest common multiple, or we can factor numbers, find matches, and leftovers and multiply, which is the way I showed you. So once again, it's your turn to try it. Use what we just talked about about least common multiple, and then pause the video. Once you have the problems worked out, go ahead and resume the video to check your work. Alright, so 14 says Danny wants to promote his new business. He gave out a free pen to every 4th customer and a free pad of paper to every 7th. Which customer will be the first to get both a pen and a pad of paper? So we're finding our least common multiple of 4 and 7. 4 works out to 2 and 2. 7 is prime, so we circle it. So I don't have anything in common between my 4 and my 7. Since I have no matches, I go to my next thing, which is bring down all my leftovers, which means I multiply all my numbers together. 2 times 2 is 4. 4 times 7 is 28. So our 28th customer will be the next person that gets both a pen and a pad of paper. Number 15 says, for exercise, Cindy swims every 6 days and jogs every 8 days. She did both today. How many days from now until she swims and jogs again? So once again, we have to find our least common multiple of 6 and 8. 6 is 2 and 3, which are both prime. 8 is 2 and 4, and 2 and 2. Find our matches. We have a 2 here and a 2 there. That's 1, 2 in common. Both of these are under the same number, so we can't count those. So we bring down our leftovers, which means we bring down 2 2s and a 3. And then we multiply them all together. 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24. So 24, sorry about that, 24 days. Now, if you need to go back or review anything, please do so. If you have questions, please make sure you ask. Raise your hand. I can come help you with anything you might have questions on. But go ahead and get onto Classroom and work out the exit ticket for our groups tomorrow.